Hi there, my name is Denny Lee, and I'm a developer advocate at Databricks. Thanks very much for inviting me to this year's PrestoCon to talk about something that I'm super excited about, which is the upcoming Delta Lake connector for Presto. Now, a little bit about myself before we continue. As noted, I'm a developer advocate at Databricks. Prior to this, I was a principal program manager at Microsoft for various teams, including Azure Cosmos DB, Project Isopope, which was the incubation team for what is now known as HD Insight, SQL Server, and Bing. And somewhere in between all that, I was also the senior director of data science engineering at SAP Concur. Hopefully, with a little context that provides my background in the data and AI space for the last 2 decades or so. So, a little bit about the company that I'm part of. Databricks provides a unified data analytics platform to accelerate your data driven innovation. We're a global company with more than 5,000 customers across various industries and more than 450 partners worldwide. As most of you might have heard of Databricks, we're also the original creator of Spark, Delta Lake, MLflow, and Qualys. These open source projects that are leading the innovation in the field of data and machine learning. So let's talk a little bit about the motivation here. Like, what is Delta Lake, and why did we work with the Presto community to build a Presto connector for Delta Lake? Well, let's talk about Delta Lake first, which is Delta Lake is one of the major open source data lake storage standards. In order to ensure data reliability, what is arguably a very unreliable system. And we're going to talk about that in a second as well. Now, saying that, since we're all here at PrestoCon, as you all know, Presto is one of the most popular distributed low latency SQL query engines for interactive analytic queries. That's great. The issue at hand is that currently, when you work with Presto and Delta Lake, you actually have to use the manifest file in order for which then allows you to register a Delta Lake table into the Hive MyStore as a symlink table type. So basically, it's basically a file that contains the list of files that then Presto will access. So the symlink file, in order to be able to figure out what the current tables are. What the current files for the table are. That's great if you are if doing interactive queries on relatively stable data. But how about if you want to go ahead and work on interactive queries on data that does change over time, or that is updated regularly or modified regular, or so forth and so forth. So that's the motivation behind saying, well, Presto being so popular, one of the things we really have to do is make it more straightforward for any Presto clients to be able to talk to a Delta Lake table to benefit for what Delta Lake offers. Now, some of the first questions you might be asking here is, why do you even need Delta Lake? Okay, so let me go backwards a little bit and provide a little of that context. So Delta Lake is an open source project that enables building a lakehouse architecture on top of existing storage systems such as S3, ADLS, GCS, and HDFS. Now, when I talk about lakehouse architecture, it's not just this idea of a marketing buzzword. It's a paradigm shift on saying the V1 world of data was typically associated with databases. The V2 world of data engineering has now shifted over to more about data lakes. So what's great about these two worlds is, in the case of databases, the V1 world, version 1 world, is that you actually had this very reliable system with ACID transactions that was simple to use, okay, or relatively simple to use. The V2 system, though, about data lakes, is that it gave you mass amount of flexibility to use low-cost object stores to store all of your data. And it gave you a high degree of flexibility to solve problems that you really couldn't try to solve with databases, the version 1. The lakehouse paradigm is like the version 3 of this world now, which is to say that, can you marry the best of these two worlds, the ACID transactions and reliability that you would normally get out of databases, with the flexibility that you got out of data lakes? And then with open source storage systems like Delta Lake, the fact is you can. right? Because the idea that you can actually have that flexibility, but also have a reliable data storage allows you to go ahead and get the best of both worlds when it comes to the data warehousing database world and the the data lake world, uh, a la Delta Lake. But that's why it's a fundamental for what we're saying is a lake house paradigm. Now, let's talk a little bit about the promise of the data lake, right? And so, what was great about the data lake is that, hey, let's go collect everything. It allowed you to do all this really cool stuff. You could store it on the Delta Lake, in your data lake without any problems. Apologies for the bias there. And you also have data science and machine learning. So now you can run your recommendation engines, your risk and fraud detection, all these other cool things directly against your data lake, and everything's done, right? Because everything's fixed, no problem at all. Problem is, and this is an old adage, garbage in, garbage stored, garbage out. Your data science and machine learning was only as reliable as what you actually stored and what you actually collected. So, how do we make this better? So, the reality of the data lake basically is that you actually have a much more complicated system. And without diving too deep into it, because we really want to talk about the Presto connector, is that you often were forced into a lambda architecture of types, okay? Or basically the real-time data would go on one set of architectures near the top, while the batch data would go ahead and process on the left side, okay? So that's why you'll see the number one here with this lambda architecture. So you had two different architectures, one for your streaming data and one for your batch data. That invariably led to the idea that I also needed to validate that and reconcile what my streaming system was saying versus what my batch system was saying. And even if I didn't have that problem, I actually did have the issue that I would need to reprocess the data, which means I would have to reprocess against your partition data. That's great. So that's stored in your data lake. And then invariably, I also have to do run updates and merges against all of this data in order to be able to do the streaming on the top side versus the AI and reporting on the bottom side. And so Presto obviously fits very comfortably in the AI and reporting side of the house. We want to make sure it can access that. But wouldn't it be cool if it can also access the same streaming data? So in other words, Presto is able to read that data at the exact same time. Well, the reality is that when it comes to these things like data lakes, it becomes a real problem because there's no atomicity inside what's stored on the object storage. So what's written there may actually not really be persistent, or end up being orphaned files. So you actually don't have a reliable reliable set of files that truly dictate what the table that you're trying to query is made out of. There's no form of quality enforcement of that data. And there isn't any form of consistency or isolation that goes with it as well. So these distractions are not just minor. They actually have a truly big impact on whether you can trust the data that you're querying. So what happens when I do this with Delta Lake instead? Well, with Delta Lake, we often talk about Delta Lake hand in hand with the process of what we often term as the Medallion Architecture. This idea that you have bronze, silver, and gold data quality levels of data as they're coming in, right? So the quality is basically derived as in bronze is your raw ingestion, silver is your filtered, clean, and augmented data, and gold is your business level or aggregate data. The idea is that Delta Lake allows you to, as part of that process, to incrementally improve the quality of your data as you're processing it so it's ready for consumption. And so again, when I look at the bronze, focus just a little bit on that one in terms of the raw ingestion. It's the dumping ground for your data. It's often you're retaining it for a very long time, and you will avoid any error-prone parsing so you can keep the data there. All right. Silver is at that point where you have intermediate data with some cleanup applied. It's queryable for easy debugging. Sometimes it's common that where you would do your debug logs, or if you're running any cool machine learning stuff, you might actually run them at this level as well. But then ultimately, your goal is where you want to ultimately query that data, whether it's for streaming purposes or for your AI batch reporting purposes. You want to be able to go ahead and reliably state, whatever aggregates or whatever details that I'm reporting against are ready for consumption and it's ready for, for example, Spark or Presto, using those examples. All right. So we've already called that out. And so the key thing that I wanted to say is like Delta Lake also supports these ideas of batch jobs and standard emails like retentions, corrections, GDPR, upserts, things of that nature. So all good things. And with this Medallion architecture, it becomes a lot easier because if you need to clear the tables, if you need to restart streams because of business logic changes, that's okay. Run the deletes at the silver and gold tables and basically restart that process from the bronze onwards, and you're good to go. You haven't lost anything. You've kept and retained all of the data, even if you have to change business logic from the past. And so, who's using Delta Lake? It's used by thousands of organizations worldwide. As we've listed here, I'm going to skip past most of this stuff. The one cool case that I want to call out in terms of like Comcast, for example, is that this is actually from one of the Data and AI Summit sessions with Comcast. That was the keynotes from the Data and AI Summit. It's about the sessionization with Delta Lake, but written by Comcast. They improved the reliability of their petabyte scale jobs. The cool thing, but because they actually were able to leverage Delta Lake to run as both a streaming and batch processing system, they were able to do two really important things. 10x lower compute. They went from 640 VMs instances down to 64. And because they could leverage streaming capabilities, they were able to run simpler and faster ETL jobs from 84 jobs down to 3, and also have the data latency. So pretty cool things, right? So just want to do some quick call outs on some of the amazing things that by having data reliability and using a system like Delta Lake, it allows you to go ahead and afford to make things more efficient and ultimately cheaper. Okay. And I'm going to skip through this pretty quickly, but there's a lot of innovation because Delta Lake, just like Presto, we're an open source project. There's a lot of innovations that are going quickly. This is a pace of innovations from April 2019 up to February 2021. We went from 0.1 to 0.8, added lots of really cool features. And then with Delta Lake 1.0, which was announced earlier this year, we also added other really cool features. I would highly advocate for you to go ahead and attend Michael Armbrust's keynote presentation from this year, the 2021 Data and AI Summit, which goes into great details about this, but things like generated columns, multi-cluster writes, cloud independence, Spark 3.1 support, PyPy install, Delta Everywhere, a key component in terms of having other systems work with Delta really, really natively, and also, of course, connectors. All right. So that segues right us back to the motivation, right? Like I said before, Delta Lake is a major open source data lake storage standard. Presto is a super popular, if not the most popular, distributed low latency SQL query engine. So, and right now, up to this point, until today's session, we can only really talk about it from the standpoint of manifest. Well, how about if we actually gave Presto the ability to go ahead and read a Delta Lake table right at runtime? So if there are any changes right at runtime at that point in time, Presto is able to automatically know which files it's supposed to access for the table, and so it has a clean read of that data. Well, that's exactly what we're here to talk about today. Okay. And why are there issues when it comes to using the manifest? Well, let's go into that, right? There's data consistency issues for partition delta tables, which may result in an inconsistent view of that delta table, right? Also, the performance, if there's a lot of data, which results in basically lots of files to be listed, the lot in the manifest, that's loaded into memory, and then it's going to be loaded in memory all at once. And if there are a lot of files for that table, there definitely is going to be a performance issue, especially after the first record, right? It's just going to take a lot of time for it to figure all that stuff out. If you look at time travel queries with the manifest file, you're not actually able to look at time travel. One of the really cool things about Delta Lake is the ability to say, what does my data lake table, what does my Delta Lake look from previous versions? Well, with a proper connector, you can actually see older versions of the data. Okay, so without getting into all of the details here, okay? Because frankly, I put a link here to give you an access to the design document. So that way you can definitely go look in the details, number one. And number two, we actually have, as part of the Delta user Slack, we have bi-weekly Presto connector meetings. So you're more than welcome to join us. And I'll put a link near the bottom for where you can find that information. But the key call out of the design is this. It starts with the Presto coordinator and Presto executor, as you see here. And as you already know, right, there's two types of JVM processes, which is the coordinator and executor. So now the Delta connector and how it coordinates its calls with the Presto main, Delta standalone reader library, the Hive store is in this form. The metadata provider, okay, that you see here is what loads the Delta metadata, which is stored in its own transaction log. So traditionally, when it comes to working with Presto, the metadata is actually stored inside the metastore. But because of the way Delta works, that metadata that tells you which files, file paths, contain what files, which ultimately make up your table, that's stored actually in the _delta _log file folder, which is a bunch of transaction log files that contain JSON files that contain that information. So we created a metadata provider that is able to, even though normally Presto is going to access that information directly from Metastore, it's going to access it from the Delta Lake transaction log instead. It still accesses the table information from the Metastore, but when it comes to the underlying metadata, it's actually going to access it from there. Okay. Any of the information concerning splits on how Presto is going to be splitting the data, that split generator, that's also included as part of and part of this code base, in which now we can figure out how to split that Delta table into multiple input splits. And then finally, the page source provider, that's the interface in which the task will get the record reader for a given split. So by building it out this way, now we've hopefully at least seamlessly made it so that Presto can go ahead and interact with a Delta Lake table without the users themselves being aware at all that they're talking to a Delta Lake table. So it's completely transparent to the users, which is our main goal here. All right. So enough to be said about talking. Let me just go show it to you. So let me dive into it here. So I've got this terminal window in which I'm logged into my local Presto instance. Do note the fact that this Presto instance is running locally on my box, though I'm actually, for the fun of it, accessing data stored in the S3 bucket. So there's going to be a little bit of latency, but I did want to call that out. And also, if I shift over here, this is the UI, the local UI that I'm running, that you can see what's going on. Here's the number of nodes that are running. I did actually have an error from a fake query, not a faulty query from before. So I'm going to go ahead and run this right now. Okay, so let's go ahead. And of course, I'm copying, pasting, let's be honest. So because I cannot type this fast. But nevertheless, let me go ahead and, oh, sorry, I am showing you the wrong screen. I'm going to go ahead and paste my first query inside here. And so right now, what's going on is exactly what you expect Presto. In this case, what it's doing, it's accessing the S3 bucket, this particular bucket for the New York City taxi data set. So this is initially going to run a little slow, but about 30 seconds or so. Oh, there you go. It is. It's done. I did want to call out that because of the way we've set this particular setup right now, what we're doing is we're actually specifying the path, not the actual Hive Metastore bucket. So because we use Delta S3 and we specify this particular path setting right here, then we know that we're actually accessing the Delta table through its file path, as opposed to traditionally through the metadata, Metastore. Yes, you have the access to the Metastore as well, but I just wanted to call that out. So perfect, you get to see the data set and you're good to go. Perfect. When I go ahead and switch back to the UI, you get to see the queries here. Exactly what you expected in the Presto UI. All the pertinent information, all that stuff is here, exactly as you would expect. So far, so good. Nothing terribly unexpected. Let me go back to the terminal again. All right. So now I'm going to run a bigger query, but without partitions. Okay. And so I'm going to run this one right now. So far, so good. Let's think here. All right. I'll show you the UI view of it now. And so it's right now planning it through. And this query should also take about 35 seconds or so. We'll see what happens. All right. Okay. It's starting to come through. It's currently running right now. You can look at the UI in terms of the rows per second and all that fun stuff. Look, at this might take a little bit longer, so my apologies for my faulty predictions. But as I did note, the fact is that it is actually trying to access an S3 bucket, so probably running a little bit longer. So now this, you'll notice, is against a non-partition table. Now there's so it's not a huge table, but nevertheless, it's not able actually to break things down faster because it's accessing a non-partition table. So what's great about it is that, of course, if I have a same query, but I'm going to this time run it using partitions, okay? Same table, except you'll notice that in this case, I'm saying New York City 219 part, because that's to represent the partition table versus the non-partition table, okay? And so I'm going to go back, and sure enough, here's the query. So this first one that I ran took about 45.82 seconds, okay? 35.86 was actually done executing. All right, let's see what happens now. And as you can tell, we're almost done here. We're looking at the UI. So significantly faster because we're actually hitting a partition table. Instead of the 45 seconds, or excuse me, 46 seconds, now we're talking about 26.88 seconds. So significantly faster, which is pretty cool. All right, so far so good. But right now, all I've really shown you is the fact that, okay, I've made it super easy for Presto to query the Delta Lake table. And that's great. Don't get me wrong. That's all good stuff. But am I actually also able to leverage some of the cool functionality of Delta Lake? And the best way for me to show this actually is to go ahead and run a version or a history table query. Okay. So here is, I'm going to show you a little bit of syntax now. Okay. Give me 1 second. Let's go back to terminal. All right. So I'm going to run this query. It'll run relatively quickly, but basically what it's doing is it's doing a select count from the partition table. Okay. Now, well, you notice here, and number one, it actually fixed pretty quickly, but you notice I have this additional syntax, the @v1. By the way, the design document that I had posted to this inside the slides, the design document actually explains exactly what we're doing here, but adding this additional syntax is basically saying, I want to look at version 1 of the table. Basically, the first set of insertions that I put into this table, this Delta Lake table. By the way, there are 9 versions to this table. Basically, each time there was an insertion, an update, a delete, or whatever else, there's a new version of the table. So you can go back in time. So this is looking at an older copy of the data. So in this case, it was looking at 8 copies ago, right? Because there's 9 total copies, and this is the first copy. All right, so far so good. All right, so again, in the first insert that I did, basically I put in 59 million rows. Cool. Let me go ahead and run a second row, which is V5, okay? Just somewhere in the middle, all right? So boom. So now I'm going to run it. And so again, it's actually running pretty quickly because I'm running against a partition table. It's only a 2-noder, but still is actually able to go ahead and make use of that. So it's actually able to split the data quickly enough and actually bring the data back and actually come back with the results nicely. And this time you'll notice version 5 of the table actually has 79 million rows. Well, 78.9 million rows, but close enough, 79 million rows. So again, I'm looking at the history. And then if I was to look at, and you'll notice right here, it says version 5. And then finally, I'm going to run the last version of the table. So right here, bam. And sure enough, it'll go run through. And when it's done, it'll actually have even more rows. And so if I go ahead and look at the UI, okay, sorry, just to make sure. Yes, right. You'll notice how the queries are running perfectly fine. If I was to look at, like just say the V1 version of this, there's actually no difference. Okay. Because what's happening here is that the Delta standalone reader, what it does, the Presto Delta connector, what it does is it accesses the Delta standalone reader. The Delta standalone reader itself is automatically able to return exactly which sets of files that belong to version 1 of that table. Because it's the one that returns that information, the Presto connector just gets the list of files it needs. So Presto actually doesn't need to be aware of this fact. The Delta standalone reader and the Presto Delta connector take care of that for you. And so meanwhile, you're good to go. It actually understands what's happening. And just to finish up what we're showing here, the final query we ran there, which is about the 9th version of the table, there's 84 million rows. So you notice that basically with this capability, now you're actually able to go ahead and make use of the time travel capability within your Delta Lake table right from the get-go as well. So pretty cool. So hopefully you guys get to enjoy using that. All right. So I'm going to switch back to the slides real quick before we take on any more questions. But saying that, I did want an important call out to do some attributions to the folks that actually helped build this. I want to call Venki, Sajith, and George. They were crucial to the help development of the project. If you yourself want to get involved with this project or any other one, please ping us at delta.io. I think it's the next slide. Yes, it is. All right. So you want to build your own Delta Lake? You want to help us with the Delta Lake Connect? You want to join the Presto and Delta community meetings that we have every 2 weeks? Just join us at https://delta.io, and all the information from the Slack user group and everything else is all available there. So we absolutely welcome you as part of the Presto community to come join us to help us improve this connector. And then saying that, if you have any questions left, by all means, this is the perfect time to ask them right now. You'll notice that I'm a bit of an Expanse fan. So yes, the quote I'm going to use as you're about ready to send any questions my way is that you can tell you found a really interesting question when nobody wants you to answer it. So hopefully I'll actually be able to answer it. But nevertheless, please do ask away. And again, if you have any questions or want to join the Delta Lake community with this Presto connector, just join us at delta.io.
Hey, everybody. Hopefully you guys can hear me now. But if you guys got questions, I'd love to hear some.
Yeah, thanks so much, Denny. That was a really great presentation. Went into much more detail of obviously Delta Lake, but the connector as well. And really good to see time travel, right? So going back in time with all the versions.
Yes, that was a big ask that everybody was going for. And so that was one of the first things we did. We did talk to the Presto community specifically about the syntax. So because originally our syntax was much more closer, to be honest, to Spark. And then based on the feedback from the Presto community, we're like, got it. We're switching this right now. And so, yeah, we have much more Presto-friendly syntax. So, I mean, for anybody that's listening, especially if it's like whether you're watching it now or watching it later, really, please do join us because we really want to take into account your feedback. So that way, whether we're working out or you guys are working it or it doesn't matter, yeah, like you can chime in and give us that feedback so we can keep on updating it. Yeah.
Absolutely. Sebastian has a question. What are some of the key features in the roadmap in the next few months for the connector?
Yeah, so right now, the two key things that we're working on is we're actually trying to do some faster optimizations, basically better memory management, so that way we can handle larger tables even faster. So one of the things that it works for pretty large tables already, but right now, candidly, there are issues surrounding the metadata in which you actually have to basically take all of the entire file listing. And so if you're talking about batch processing, that's honestly not that big of a deal. But if you're streaming data into that Delta Lake at the same time, the idea that you actually have to read the entire file list in memory and then tell Presto what it's supposed to do can actually be very memory intensive. And so the context is that we're going to change that up by adding in an iterator specifically to speed up processing of that. In terms of farther out, obviously there's going to be features and functionalities as in like, can we do better partition pruning, things of that nature. So we are definitely looking at that. But the other big call up that I wanted to say is that we are starting to, and again, that's why love to get feedback, is to go ahead and is there interest for the Presto to Delta writer as well? Right now, the vast majority of people are asking for reader, so that's why we focused on that one first. But are you also interested in writing? So if you are, again, please chime in. Incidentally, we're going to be publishing the proposed roadmap, I'd say in mid to late January. For Delta Lake, and specifically, obviously, for this audience, the Delta Lake connected with Presto. So we're going to want you guys to chime in and tell us what you want out of this. Okay, so right now we're getting a little bit of feedback that, like for example, CTAS operations are the desired flow. Yes. Cool. That's actually honestly relatively easy, so we can do it. But by the same token, if there's some more complex scenarios, love to know about it so you can chime in. And then I did notice, Denise, hopefully I'm saying your name correctly, at least myself used to living in Montreal. I'm assuming that's French, so I apologize if it's not. Does at v1 syntax work in Spark SQL as well? Not right now. In fact, we're going to go back and do some pull requests into the Spark community to accept that syntax. This is a very Presto specific syntax, and it is not actually ready for Spark SQL yet. So we specifically wanted to have the Presto community have access to it first.
Sounds good. Thank you. And then on the right path, I wanted to say that CTAS is something that some of the other connectors already support, right? For the other table
That's
formats,
right.
It's a good place to start. We are also looking at just basic, IUD operations.
Mm-hmm.
Start with inserts first, most common, and then look at updates, upserts, deletes, and so on.
Right.
Those get more complicated. It basically touches the entire, code path from the parser all the way down to the writer itself, and that's something that Ahana is looking at adding in from a write path as well. So,
Awesome.
Just the last question on catalogs. Is there a preferred catalog? And,
not right now, no, because
who works with HMS?
No, there isn't actually a preferred one. I mean, we're going to be compatible, like at least the ones we've been testing is more like the Hive Metastore, HMS, and like Glue, for example. There's no big requirement, but the part of the reasons is the context, at least, is that the vast majority of the metadata that's read actually is not read from the Metastore. The vast majority is actually read from the transaction log. Now, what we've done with the connector and also using the Delta standalone reader is that basically that metadata, it's completely transparent to Presto whatsoever in terms of it doesn't need to know that it's grabbing the data from the transaction log, which is basically a file system, versus actually reading from the Metastore. The reason Delta Lake was designed this particular way was to allow for much larger scalability. We're talking about hundreds of petabyte systems, which normally operate where basically, candidly, we would see the Metastore fail. And
Right.
so because of those scenarios, we're like, that's why we did that with the file
Right.
system. But because of that, we wanted to make sure that from a Presto perspective, didn't matter. Like it plainly didn't matter. So the cool advantage, by the way, and thanks for the question, Rohan, is that in addition to be able to query through the Metastore directly itself, you can also query directly through the file path. So you actually have both options now. So.
Awesome. Well, Denny, thank you so much. We're out of time, and our drummer must be going on in the other room. So we're going to go join him and close out the session. Dennis, Bastian, Rohan, thanks for the questions. Looking forward to the right path being executed as well. Next PrestoCon, hopefully we'll have both in and out.
Exactly.
Thanks, everyone. Cheers. Thanks, Denny. Bye.
Thank you. Take care.